For 8 days last July, 3 men argued about a piece of steel smaller than a pencil eraser. One of them said it was too small for heat to matter. One said the metal and the bore around it swelled together, so heat never got a vote. And one said the whole answer was hiding in the steel itself. 8 days, nobody backed down, nobody landed it. The piece of steel they were arguing about is the piston from a Cox .049, a model airplane engine that sold in American hobby shops for $3.95. And the argument exists because of what this piston does not have. Every engine in every driveway in America seals its fire with piston rings, sprung metal hoops wrapped around the piston, pressing out against the cylinder wall. Engineers will tell you an engine cannot run without them. The fire pushes hard enough to leak past anything loose, and the rings are the only thing holding it in. This piston has none. No rings, no grooves for rings. Nothing seals it. And yet it held its fire an inch from a boy's thumb, screaming at 15,000 revolutions per minute. And many of them hold it still, 60 years later, on the first flip. So that is the question those 3 men could not close. And it is the question of this film. If nothing seals it, what keeps the fire in? The answer is not a part. It is 3 decisions made inside one building in Santa Ana, California, that nobody standing outside ever saw. Part of the answer is known. If this channel has told one story about this engine before, it is this one. The piston is steel, and the cylinder around it is steel. So when the engine gets hot, both of them grow together at the same rate, like one piece of metal. That is why nothing wears out. But listen to what that sentence actually promises. Growing together keeps the gap between them constant. It does not make the gap tight. If the fit is loose when the engine is cold, it stays exactly that loose when the engine is hot, faithfully, forever, loose. One of the men who restores these engines put it in a single line. A ringless piston needs a good fit in the cylinder even when it is cold. So matched steel is not the secret. Matched steel only protects the secret. Somebody, somehow, had to make that fit nearly perfect before the engine ever fired, and had to do it not once, on a workbench, but at a scale almost nobody believes when they first hear it. The building was on Warner Avenue in Santa Ana, California, and at its peak, 250 people worked there, turning out, in the best years, more than 1 million engines. A man who walked that floor never forgot it. Rows of automatic screw machines turning cylinders, rods, cranks, and pistons out of long, round bars of steel. He said they looked like Gatling guns. Across the aisle, another row of machines made the fuel tanks and crank cases. The air in the first operation area smelled of cutting oil, and down by the molding presses, it smelled of hot styrene. And in the middle of it stood machines that existed nowhere else on Earth, because the man who owned the company had built them himself. Leroy Cox did not trust anyone else's equipment to hold his standards, so he designed his own. Rotary tables ringed with stations, each station performing one cut, one bore, one port. The parts rode around them like a carousel, and every time a raw slug of steel went on, a finished part came off. The workers called them Cox-O-Matics, a toy company. With machine tools it had to invent for itself, because the machines it needed did not exist. Now hold on to the problem. A ringless piston needs a nearly perfect fit while cold. This factory made over 1 million engines a year. Every single one needed its own perfect pair. How do you do that 1 million times and never miss? Start with what the argument on the internet got wrong. When collectors argue about how these engines seal, someone always brings up the taper, because Cox's racing engines had a cylinder bored fractionally narrower at the top, to stay tight where the fire burns hottest. It sounds like the secret. It is precise, it is clever, it is exactly the kind of detail that wins an argument. Except the man who ran engineering for Cox said the opposite. The low-end engines, the $3.95 ones, had a straight bore. And in his words, that made it easier to assure a perfect seal and easier to start. The taper on the racing engines actually reduces the seal at the bottom of the stroke. It makes them harder to start. The taper was never the sealing secret. The taper was a price, paid on a handful of high-strung racing models for speed, which leaves a fact almost nobody in that argument would have guessed. The tightest sealing, easiest starting engine Cox made was not the exotic racing model. It was the cheapest one on the shelf. The one on the drugstore counter. The one a 9-year-old could afford. The best seal in the line went to the boy with $3.95. So here is the first of the 3 decisions. The piston and the cylinder were not made of 2 cleverly matched materials, chosen from opposite ends of a metallurgy chart. They were cut from the same mild steel bar stock, the same metal. Sometimes, effectively, the same bar. That is the move. 2 parts cut from one material do not merely expand at similar rates, they expand as one thing. Whatever the temperature does, it does to both of them equally. The gap between them is locked, not by control of heat, but by kinship. One of the restorers said it plainly. From pure physics, a ringless piston is best made of the same material as its cylinder. And modern hobbyists keep proving it by accident. You can buy aluminum replacement pistons for these engines today. Machinists who have tried them will tell you aluminum against a steel bore needs the wrong alloy entirely. The ones on the market do not have nearly enough silicon in them to survive. One veteran called an aluminum piston in a steel cylinder what it is: a suicidal combination. Aluminum swells more than twice as fast as steel. Hot, it grinds. Cold, it leaks. Steel in steel does neither. It just breathes in and out, together like one chest. Decision 1, then, give the 2 parts the same blood. But that only makes the fit stable. It still has to be made. And the making is where this story stops being engineering and starts being strange. Before the strange part, the ritual. A Saturday morning, somewhere in America, around 1962. A boy kneels on a driveway with a plastic airplane and a father who has given up pretending to read the newspaper. The routine never changed. Fill the tank with the sweet-smelling fuel. Press a fingertip over the little exhaust port. Turn the propeller through to prime it. Hook the battery clip to the glow head, and then flip and flip and flip until the thumb was raw at the knuckle. When it finally caught, it did not putter. It screamed. A piece of steel the size of a walnut, howling an inch from a small hand, spitting castor oil that got into a shirt and stayed through 3 washes. 60 years later, the men who were those boys mostly remember the smell first, then the sound, then the thumb. But there is one more memory, and it is the one this film is about, even though almost nobody realized what they were feeling. Turn that propeller slowly with the engine cold, and somewhere near the top of the stroke, the piston leans into the cylinder. A soft, springy resistance, like pressing a thumb into a new tennis ball. Machinists call it the pinch. A boy just called it the engine pushing back. That pinch was the fit. That was a factory in Santa Ana, felt through 2 fingers, decades after the factory went quiet. Now the strange part. Because when the restorers who take these engines apart talk about the 2 parts of that fit, they say something that sounds backwards. The piston, the moving part, the part you would expect to be sacrificial, is harder than the cylinder it runs in. The cylinders, in one machinist's blunt words, are soft. Stop on that. In almost every engine humans build, it is the other way around. The cylinder is the fortress. Pistons and rings are the wear parts, the things you replace. Cox built a soft fortress and sent a hardened piston to live inside it, and the result outlasted almost everything else made in America that decade. Why would anyone harden the moving part and leave the wall around it soft? Hold that question. It has an answer, and the answer is the single best manufacturing decision in this whole machine. But to earn it, you need to see one more piece of evidence, the one sitting in dresser drawers all over America right now. Collectors who buy old engine lots know the pattern. An engine that ran hard for years and got put away dirty will often be found frozen, not rusted, not broken, seized. One collector described his boxes of old engines simply: "The tolerances are so tight, they are seized." What a wonderful failure that is. These engines do not die the way machines die. They do not rattle themselves loose, wear themselves hollow, and finally clatter apart. They sit for 50 years, the old castor oil slowly turning to varnish in a gap thinner than smoke. And they lock up from closeness. The fit does not fail. The fit wins too hard. Which sharpens our question to a point. A fit that tight enough to seize half a century later on more than 1 million engines a year. Not one hand-fitted masterpiece. 1 million. How? The answer came, years later, from the man who would know, Cox's own director of engineering and quality control, the engineer behind the company's fastest racing engines. Long after the factory closed, he wrote down, in 2 plain sentences, the thing this whole argument was missing. The pistons were copper-plated, and then the copper was ground off the outside. That sounds, at first, like the fastest way in America to waste copper. Plate the whole part, then grind the plating off. But watch what happens at the next step. The bare steel piston goes into a furnace to be hardened, a process called nitriding, which only bites into surfaces it can touch. The outside of the piston, freshly ground bare, hardened. The inside and the crown, still wearing their copper coat, untouched. The copper was never decoration. The copper was a mask. One piece of steel goes into the furnace, and 2 different parts come out. The outside skin, the surface that must slide against the cylinder for a lifetime, comes out hard as a bearing. The inside stays soft. And it had to stay soft because of one beautiful detail. This engine has no wrist pin. The connecting rod ends in a little steel ball, and the soft inside of the piston is physically folded, swaged around that ball, wrapping it like a fist closing around a marble. Hard enough outside to never wear. Soft enough inside to be bent around its own bearing. One part, one furnace, 2 fates. And here is the detail hiding in plain sight. Anyone who ever unscrewed the cylinder and tipped out the piston has seen it. A warm reddish glow inside the little steel cup and on its crown. Most people who noticed it in the last 50 years assumed it was some kind of plating for its own sake. It is the leftover mask. The copper is still there on the inside for one reason only, because on the outside they ground it away, which leaves the soft cylinder and the answer to the backwards question from before. Fair warning about what follows. This is the kind of knowledge that never made it into a manual. No textbook teaches it this way. It lived in the heads of the people who stood at the lapping benches, and it mostly left when they did. The final fit of piston to cylinder was made by lapping, rubbing the 2 surfaces against each other with a fine abrasive paste between them until they matched. And lapping has a law that sounds like a riddle. The abrasive does not simply grind both parts. The grit embeds itself into whichever surface is softer, and once embedded there, it stops cutting the soft part and starts cutting the hard one. It is worth hearing twice. The soft part becomes the file. The hard part gets shaped. So the soft cylinder was never the weakness in this design. The soft cylinder was the tool. Every soft steel bore, charged with abrasive, became a custom-made file in the exact shape of itself, and it carved its own hardened piston to a private, perfect fit. The 2 parts did not meet on a blueprint. They met in each other's hands and ground themselves true. There is a quiet rule of the workshop buried in that, and it reaches well past engines. In a well-made pair, the softer one is not the lesser one. Sometimes the softer one is doing the shaping. Put the 3 decisions side by side, because separately they are clever and together they are something else. Cut both parts from the same steel, so heat can never open the gap. Mask the piston in copper and harden only its outer skin, so one cheap part can be bearing hard outside and folding soft inside. Leave the cylinder soft so that in the lapping room, every bore files its own piston to a fit no catalog ever printed. None of those 3 decisions is visible on a parts diagram. There is no component called same blood, no part number for the mask, no entry in the catalog for the bore that files its own piston. Take the engine apart on a kitchen table and you will find none of them. You will find a piston with no rings and a mystery. And all 3 decisions belong to a company where the owner had built the production machines himself because he did not trust anyone else's to hold the line. This channel has said it before about this factory, and this engine makes it true twice. Scale was not the enemy of that precision. Scale was the condition of it. Only a line running millions of parts could afford to turn every single cylinder into its own finishing tool. And then the man who built all of it sold it. There was a moment in the good years when the company showed off, and the way it chose to show off tells you everything about what those 3 invisible decisions added up to. Visitors were walked down the production line, and the tour guide, moving from station to station, would pick up parts as he went. A cylinder from this machine, a piston from that one, a crankcase, a rod, raw output, straight off the line, chosen by nothing but the moment. At the end of the walk, he handed the pile to a service technician. The technician assembled them into an engine in front of the visitors, fueled it, and it fired on the first flip. Not a hand-picked engine, not a matched set. Random parts off a running line, and it fired. Other factories published their tolerances. This one performed them in front of strangers as a party trick. That is what it looks like when a fit is not inspected into a product, but built into a system, when the millionth engine is fitted as perfectly as the first, because the system itself does the fitting. And of the people inside that system, the ones standing at the lapping benches, the ones whose hands actually made 1 million perfect pairs a year, the record keeps almost nothing. Nobody wrote down their names. Nobody photographed their hands. There is no interview, no memoir, no roll of honor for whoever it was that learned, engine by engine, what tight enough felt like through a fingertip. A visitor remembered the smell of the cutting oil in the first operation area. That sentence is very nearly their entire monument. That and the engines. Every seized, stubborn, 60-year-old engine in a dresser drawer is their signature, pressed into steel. The dates after that go quickly, and they do not need decoration. In 1969, Leroy Cox retired and sold his company to a toy conglomerate called Leisure Dynamics. In 1981, he died. By 1983, Leisure Dynamics stood at the edge of bankruptcy, and the man who stepped in to buy the engine business back was Bill Selzer, the engineer who had drawn the $3.95 engine in the first place. He saved it, and in 1996, it was sold again, and the operation left Southern California for good. The machines could be sold, the molds, the drawings, the name, all of it could be sold, and all of it was. The one thing that never appeared on any bill of sale was the thing this film has been about, the hands that knew when a fit was tight enough. But the engines are still here. In boxes, in drawers, in garages, most of them still hold that pinch at the top of the stroke. And a shocking number of them, 60 years on, still fire. A man who grew up on these engines could close his eyes tonight, turn a small propeller slowly with 2 fingers, and feel it again. That soft pushback near the top, the engine leaning into his hand. For 8 days last summer, 3 men argued about what that pushback was. One blamed the size, one credited the balanced growth, one pointed at the steel. All 3 were partly right, and the argument still would not close, because they were all looking for the seal inside the engine. It was never in there. It was in a choice of 1 steel instead of 2. In a copper mask, ground off where the fire would live. in a soft bore quietly filing its own piston, one of a million that year, in a building in Santa Ana where the machines had the owner's name on them and the lapping hands had no names at all. Nothing seals it. That was true all along. Nothing seals it, except everything they decided before the fire ever lit. If you think those three men were wrong, or if you think this film is, the comments are open, and this channel would rather be corrected than agreed with. And one request, made in earnest: somebody lapped those pistons. 1 million a year, by system and by hand, and not one name survives. If you worked the line in Santa Ana, or your father did, or your mother did, even a summer job, you are the primary source. This story is still missing. Say so below. Every comment gets read, and the best get pinned. The Last Whistle tells the true stories of America's vanished hobby brands. If machines like this one deserve to be remembered properly, subscribe. There are more of them.